Hi folks, I'm Dr. McNamara and I'm your lab instructor for this Stat 220 lab. We're going to be using R and RStudio as our software in this lab, and we're going to be using a cloud-based version of RStudio, which is accessible through the browser. So I sent you a link on Canvas, which will allow you to sign up for my space on RStudio Cloud. And when you go to that URL, you'll get taken to a page that looks like this. And if you have a Google or GitHub account, you could just use those to log in. But most people are probably going to need to sign up. So you put in your email address, you come up with a password, you enter your first and last name, and you sign up. And once you have your login information, you'll need to log in to RStudio Cloud. So when you log in, it might take you to a page that looks like this, and then you just need to go back to that URL that I sent you on Canvas. And then it's going to ask you if you want to join my space, and then you'll have to click Join Space. And then it'll say something like, welcome to this space. And then what you're going to need to do is go to projects. And there should just be one project available to you. And it'll have my name and it'll say Start Labs. So click on that project to get it to open up. And this part might take a minute. So this is RStudio getting everything started for you behind the scenes. And sometimes it hangs like this for a little while. So we'll just be patient. Okay, so this is what RStudio looks like. It has a few panes which are going to allow us to do the useful things that we need to do in R and RStudio. This is the console pane right here, and this acts sort of like a big calculator. So you could do like 2 + 2 and hit enter, and it will tell you that it is 4. Or you could do log parentheses 2, and it'll tell you it's 0.693147. Or you could do sqrt parentheses 100, and it'll tell you that the square root of 100 is 10. R works like a big calculator. It can do anything that your fancy calculator can do, but then it can do a lot more than that. And every week I'm going to go through a pre-lab with you, which is going to tell you how to do the things that you need to be able to do for the real lab. So I've set some things up for you in the Files pane. I've already added some files to RStudio for you. So I have a folder that's called Labs, and I'd recommend that you store your real labs in there. And I have a folder that's called Pre-Labs, and I'd recommend you store your pre-labs in there. I've also given you a file which has an overview of all the R code you're going to need for this semester. So that's kind of like a cheat sheet. And then the .r history and the project.rproj, those are just files that kind of make things work on RStudio, so you don't need to be concerned about those. So what I want to do is start with a pre-lab. So I'm going to click on the pre-labs folder to get into it. And then there's a data folder inside it. And then there's this file which says something like stat220 describing data pre-lab. So if you click on it, then it'll open up another pane in your RStudio. So this is a file format called R Markdown. If you could see the end of this file name, it says .rmd here, which is short for R Markdown. So R is a programming language. It can do this calculator kind of stuff, and it comes with functions like log and square root already built in. But what makes R really powerful are these additional packages, which is more R functions and data sets and documentation all packaged up together. And anyone can write an R package and make it available for everyone to use. So I've contributed to some R packages myself, and as you get better at R, maybe you could do the same. But we're going to use 3 packages in this course. So I'm going to just scroll down a little bit in my describing data pre-lab. And there's some code here in a chunk. So a chunk always starts with tick, 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 curly braces. Sometimes there's stuff inside the curly braces, and it ends with tick, tick, tick. And in between is code. So I've set some options for you here. You can ignore those for right now. And then I've put some code in here to load a package called lock5data. So that goes with our textbook that's written by Lock, and Lock, the 5 locks. So this will have some data that goes along with the book. So I'd like to run this line of code so that I have access to those functions. So one way that I can do this is I can just hit the green play button on the chunk and it will run that code for me. This line that's in green text with the pound sign is a comment, and it's just giving you some instructions. It says put in the other 2 packages you need here. So I'm going to delete that, and then I'm going to type the other packages that I need. So I'm going to type the library command, which is going to get a package out of my library. And the packages that I need are Mosaic, M-O-S, and then I'm going to hit enter, and then I'll do library parentheses GG formula. So those are the 3 packages that we need. Again, if I want to run all that code, I could hit the green play button. Some code is going to run by here, and it's in red, which makes it look like it's an error, but it's actually just giving you some information. So this is all good. It actually worked. And the thing that makes R cool and allows us to do statistics is that it's really built around working with data. So I have an example data set that I've created that I use for all my pre-labs. It's in the data folder. You can see it here, gss clean.csv. I'm going to jump back to my pre-labs folder. And I've put a chunk here to write some more code. And it's got a comment, this is where the data loading code goes. I'm going to delete that. And then I'm going to type some code which will allow me to read in a data set. And I'm going to call this data set GSS. I could name it whatever I wanted. I could name it Amelia, that's my first name, or I could name it My Cool Data. I'm going to call it GSS because it's from the General Social Survey, so that'll be easy for me to remember and it'll be easy to type. So GSS, and then I'm going to type the assignment operator for R, which is a little arrow. So it's the less than sign and then a dash. So that's the assignment operator. And then I'm going to type the function that lets me read in some data. So I type read.csv. You can see that R is trying to help me out. It's saying, oh, do you want read CSV or read CSV2? If I hit tab, it'll complete that piece of code and it'll put the parentheses in for me. So I'm going to read.csv. Then I need quotation marks inside here, and then I'm going to give it the file path to the data set that I need. And if I know about file paths and they need slashes in them, I could just type it out, but I find that the easiest way to do this is just to hit tab. And this will show me that there is a data folder, and if I hit tab, it will write data slash, and then I only have one data set in here, so that's my only option. If I hit tab again, it'll complete that all out for me. But I could have written that by hand. data/gss_clean.csv, close those quotation marks, close that parenthesis. Okay? So now I'm going to hit the play button on this chunk of code, and something happens in my console. Nothing prints out down here, but a new thing appears in my environment. So the environment shows me everything that I've loaded in, like data or variables, and it gives me some information about this data set. So it says 2348 obs of 45 variables. So that's already pretty useful. This data set is from the General Social Survey, which is a representative sample of households in the United States. I think this particular data set that I'm giving you is from 2018. I think that's the most recent complete version they have. And I've taken a subset of it and done a little bit of cleaning, so it's a little easier to use, although there's going to be some messy aspects, which we'll see as we're working through it across the labs. So that, I think, is the only code that you need to learn for this week in lab. You need to know how to load a data set. So you need to use the read.csv function, and then you need to put the name of the data set in quotation marks like this and give it a name. So that's all the code for this week. But we need to also look at our data set. And while we're going to be doing programming in this course, for the most part, you can do this whole lab just by clicking around in RStudio Cloud. So I've written out some questions here, and I'm just going to kind of answer them as I go. So the first question is, what are the cases in the data set? And I might want to look at my data set to get more of an idea about this. So I'm going to click where it says 2348 obs of 45 variables. And then that pops up a kind of spreadsheet preview of my data set. So I can scroll around. So I've got variables like number of children, age of respondent, highest year of school completed, highest year their father completed, their mother, their spouse, what their college major was, if they got their high school diploma or not, what their sex is, how many brothers and sisters they have. It goes on and on. There's a bunch of variables, 45 variables in here. The GSS actually collects a lot more variables than that, but I just picked out some that I thought were interesting for you. The first question asks, what are the cases in the data set? And it looks like they're people. So the observations or the individual rows in the data set are people. Then it says how many cases are there, and there are 2,348. I can tell because it says that in my environment. So I can just read it off of here. If I wanted to, I could write some code to do this. Maybe I'll do it right now just because I could insert a new R chunk. And then I could say n row for number of rows, GSS. And if I hit the play button, it would show me how many rows there are. Okay, but that's not really necessary for this lab. You could just look at it and then type it out in a sentence for me. And then it says, is there any missing data and how can you tell? So let's go back to our spreadsheet-like version and just scroll around. So right away, I can see that there are some NAs for highest year school completed father. So that's some missing data. Lots of NAs for highest year school completed spouse. Maybe those people aren't married or they didn't want to report it. We're missing some college major 1, college major 2, not everyone double majors. So yeah, we've got lots of missing data. So I'll say yes. There are many variables with missing data, including highest year school completed father, highest year school completed spouse, college majors, and many more, I'll say. The next question asks what the variables are, and here there are 45 variables. Some are, and let's go look, number of children, age, highest year of school completed, etc. And then the next question asks us to name a couple of variables that are quantitative and a couple that are categorical. So if I look here, I'm just looking for the things that look like numbers and the things that don't look like numbers. So some numeric things would be number of children or age of respondent. But then if I scroll over college major 1, that's categorical. Diploma, GED, or other, that's categorical. So quantitative, number of children, age, highest year of school completed. Categorical is college major, diploma, or GED. What else did we have? Sex, labor force status. So those are a few. Then the next question asks us to pick out an observation to write about and find some characteristics of this observation. So I'm just going to go click over here and let's see. I'm going to look at person number 7 because I like the number 7. So they have 6 children, 6 Wow, and they're 59 years old. So they have 6 children. They are 59 years old. They completed 13 years of school, so they did 1 year of college. Don't have information about their father's schooling. Their mom completed 6th grade. Oh, I keep losing my spot. We don't have anything about a spouse or a college major. They got a high school diploma. They are female. And they had 7 brothers and sisters. Okay, so maybe that makes sense. They had 7 brothers and sisters. They had 6 kids. They have a high school diploma. They are female and had 7 brothers and sisters. So that is one observation. And we could go further along across and learn more about them if we wanted to. Then it asks, is this a random sample? That's not something I can see by clicking on the data set, but I told you that this was a sample of US adults when I described the data. So yes, it is a sample of US adults. Is it an experiment or an observational study? So what do you think about that? It is an observational study. Observational study, because experimenters aren't manipulating anything about the environment. Could we use the data to determine cause and effect? No, because this is not an experiment. Even though it's random, we can't find cause and effect because it's not an experiment. But what is a question that we could answer using this data set? Well, we could see if, do older people have more siblings? I'd kind of guess so. It kind of feels like it used to be that older people, that there were more siblings and now we have fewer siblings. We could say how many people have high school diplomas? Are there more unemployed people with a GED than not, etc.? So we could ask questions about the variables like that. And you could have thought of some different questions, and on the real lab, you're going to have a different data set to think about questions for. And then you're also going to need to think about for your project, what's a question that you might like to answer, and would it be possible to get that data? What would it look like? Things like that. So those are things that you're going to need to answer for the real lab. So the last thing that I want to show you is about this document format. So as I've been working in this document format, the name of my file changed from black to red, and that means that I've made some edits that haven't been saved. And the easiest way to save my work and to make something kind of finished is to click this knit button. So let's try it. So again, whoa, that happened really fast actually. I don't know if you even were able to see that, but a bunch of things scrolled past very quickly in this R Markdown tab, and now another window has popped up on my computer. And in the popped up version, everything is really nicely formatted. So in the original file, I had this sort of header where I had used 3 dashes and put some information like a title and an author and some stuff about a table of contents. And now that title is being made nice and big like this. It's got my name in bold, places where I wrapped a name of a function in backticks. It looks like code inside my sentence. Anywhere I used pound, I get a heading. And then if I have something where I have added some code in a code chunk, I get the code, and then it runs the output when it knits this document, and it puts the output right in there for me. So this is a knitted document. So it comes from our Markdown and it becomes an HTML file. And this is what you are going to need to turn in for your lab. So this is just a little preview to let you see it. So we can X out of this. And if we go over here to our Files tab, I'm still in the pre-labs folder. And when I started, I just had one file here, which was a .rmd file. And now that I've clicked that knit button, I have two files here. And the second one has the same file name as my .rmd. It's a really long file name, but it says .html here. So I've got this HTML file, which is what I actually want to turn in. And the only tricky thing is that this file is sort of trapped in the cloud, so you need to get it down onto your actual computer before you can upload it to Canvas. So the way to do that is click this checkbox next to the file and go to the More, and then click Export. And this will say, you know, what do you want to name it? I'm just going to keep it the same and click Download. And then it's going to ask me if I want to save it. Yes, I'm going to save it onto my computer. My downloads go into my downloads folder. Yours might go onto your desktop or your documents. You'll have to figure out where it goes. And then you're going to submit that assignment to Canvas. I actually have a separate video, which is just a quick reminder about that whole process in case you ever forget.